Last week, I did a live stream walking through the entire codebase of my Playdate game, Escape from Complex 32. I went ahead and cut it down to a shorter video and added timestamps, so I hope it's helpful. Enjoy! I just want to go over the source code for my game, Escape from Complex 32. I think that it would be beneficial to kind of have an idea of like what complete game, albeit a small game, could look like. Because game architecture is kind of a topic that doesn't get talked about a lot. Like even in like big engines like Unity or Unreal or Godot or whatever, it's like easy to talk about like, oh, how do I make this character controller? But like just the entire source code is kind of different. So yeah, let me jump right into my source code. First, go over basically my file structure. You'll see these comments here. These are from my Patreon supporters. So if you're a Giant Squid patron, I usually send out the source code for my games. I leave a bunch of comments. You can read them or you can ignore them for now. I have this background file. So this background is kind of what controls the infinitely scrolling walls. I actually have one overarching obstacle class that everything extends from, which makes things really easy because in the player class, I handle collisions by checking the type. So that's kind of why that was important. I also have a player class. This has to do with the player itself, and then also the laser beam, the laser gun, the timer, and all that. Yeah, and then I have the UI, and then I split that up into everything UI related. So that has to do with the results display, like showing the high score and everything. So how I handle the scene transitions, I have two different scene files. So there's actually only two scenes in the game, the title scene and also the actual game scene. So these are these two files. They handle all the initialization. Outside of the game and the title, I have this globals file that handles a lot of things that basically is globally accessible that I use across the project. It's just nice to kind of organize it like that. And then I have a scene manager that manages like switching between scenes, the transitions. And then of course the main file. Now after going over this overview, I'm gonna go into the main file and then just talk about how things are structured. You'll notice that if you take out the comments, my main file is very clean. There's not that many lines, so it's like 20, 30 lines. The reason for that is because a lot of your work with code architecture is not necessarily has anything to do with like how the game runs, but it's more so that you can organize everything in your brain. And it makes it so that when you add things or change things in your code, it's very simple to do so, or it's enjoyable to write code. So there's no like reason to have like a short main file other than the fact that for me, it's just easier to understand. Yeah, so basically all I'm doing is I'm setting a global variable, this max height, which I use to keep track of the max height. And then I load the game data. So this is actually part of the global file. I want to make a quick note on globals. So if you remember if you watch my videos, I talk a lot sometimes about like using local instead of global scoping. The reason is because when you make a lot of globals, what happens is you have essentially invisible lines of data paths going across your entire code base. What happens is it's very easy to lose track of your data that way. It's like confusing to write and to update your code because what could happen is you update a global variable. Let's say I change this to 1 instead. What happens is I don't actually know where this max height is used elsewhere in the code. Obviously you can search for it like max height. I could find it, but in reality, like it's easy to make changes to global variables and have it impact your entire code base and create bugs that you don't know about. So that's why I recommend limiting your scope to like locally, so you know that at the very least it's within this file, or if it's in like a function, it's within the function. I have like 5 global variables in the entire project. Yeah, so I keep checking this max height global variable, one of the few global variables I have, and I load the game data. So I can pull up the globals file right now. So you can see not that many global functions that I'm using, but basically I had these things not as globals, but I basically went back in my code and replace them with these globals if I found that I was using a function like across multiple files. So save game data, this is just, I'm saving the max height into the data store. So that's how when you exit and restart the game, like it saves the data. And then I'm initializing the scene manager. The scene manager, let me pull this up. This is a class that I made in order to handle scene transitions. So this is kind of a question that I hear a lot, and is also kind of confusing for new developers or developers who've only worked in game engines like Unity or Unreal or Godot or whatever, is the concepts of scenes. So traditionally in games, you find a lot of scenes like a title scene, and then there's like a game scene, and then maybe there's like a menu scene or like different levels that are their own scenes. But when you're working with an SDK, it's not like a built-in functionality to have scenes. So you have to create your own, essentially create your own implementation of it, or use a framework someone else has used. I believe the Noble engine that handles all that for you that you can use for the Playdate if you would like. But this is my own implementation. So this is how I do the transition. So the circle transition effect, basically, it's a class, and the scene manager itself is a sprite, which has implications. I'll touch on that later. Whenever you want to switch a scene, you would call the switch scene function and then pass in. I'm expecting to be a function, which is just a series of calls that initialize a bunch of sprites. So what's unique about my scene manager system is I'm assuming that everything related to a scene is actually a sprite, that's just a design decision that I decided. It's just arbitrary, but I feel like it makes things easy because for sprites, updates are self-contained. You can easily remove all the sprites using GFX that sprite that remove all. And since for each of my scenes, everything is a sprite, removing all the sprites in the game will effectively delete an entire scene. Let's just take a quick look into my game scene. I said I was passing in a function. That's this. I'm passing setup game. Or actually, sorry, game scene is actually an object. This can be a function or I guess an initialization for an object. What's happening is it's calling all these functions, these initializations for all these sprites. So each of these is actually a sprite, a class that extends the sprite class. So I'm basically creating 5 sprites. This is the creation of the scene. There's no right or wrong way to do it, but this is just what I found to make most sense. Yeah, everything in my game is contained within the code of these 5 sprites. And then these sprites can spawn other sprites. For example, the obstacle spawner spawns more sprites. When I'm switching to the game scene, it's this game scene object that's being passed in and being stored into this new scene property. So when we call switch scene, what happens is I create an animator, and this animator is animating between a circle radius to 0. And it's using this easing function. So basically, this radius will be some sort of value, and then it'll be easing into 0, right? So that's like the transition. I guess it's a number. It's a number. This radius to 0, and it's going down over this amount of time. It's transition time, so 700 milliseconds, 0.7 seconds. While we're updating, we'll see that it's actually, this is not null anymore, and then the transition will begin. How I do the transition is I get this filled screen rec. So I create a helper function. What's happening is I'm creating a new image, the size of the screen. I'm using push context, and I'm creating a rectangle, the size of the screen. Filled screen rec is now a black rectangle that's the size of the screen. And then I get the radius from the transition animator. And then I'm creating basically a clear circle. I set the color to clear, and then I use fill circle at point to draw a circle of radius based on the animator. And then I use it to basically cut a hole in the rectangle. And then I set the image of the scene manager, since scene manager is a sprite, and that's happening every frame. The dimensions of this is actually, it's 400 by 240, and the radius is 300. This big circle, what's happening is I'm basically cutting this hole. So basically this whole thing is gonna be white. As the radius becomes smaller and smaller, what happens is there's like a smaller circle like this, and then this is what's being cut out. The radius becomes even smaller, and then this part's being cut out like that. So you can imagine that it's this animation where I'm just cutting out a smaller and smaller circle into this black rectangle, which is called, that's what's making the transition effect. What happens is, so now I have this cutout rectangle, and then we're resetting the image on the sprite. So basically, it's every frame is redrawing that rectangle and setting it to the image, which is creating the animation. Once the animation has ended, this is when we load the new scene. Load new scene does this. So basically, I remove all the sprites, and as I mentioned before that all my scenes are consisted solely of sprites. So basically, this is deleting the last scene. Because the scene manager itself is a sprite, you have to re-add the scene manager itself. And then I create a new animator, but this time you can see it's the opposite of the last one. So it's going from 0 to the circle radius, as opposed to the radius to 0. It goes in and then reverse goes back out. And then I call this new scene. So let's say we're switching to the game scene. I'm storing the game scene object into this new scene. And by doing this, I'm basically initializing the game scene. So this self.new scene is calling game scene init, this init method. When the scene is transitioning and the circle closes in, then it loads the new scene, and then it starts transitioning out. So while it's transitioning out, you can see like the game will be there. So this is the background. This is how I handle the infinitely scrolling walls on the side. I have this sprite. This is bigger than the size of the screen. So only this middle section is being drawn into the game. And as the player moves up or down, the screen is essentially going up. And then once it hits to this point, the screen hits the very top of this image or the sprite, then I shift it up. I'm creating these collision boxes. So just, the collision boxes on the left and right. And I'm setting the groups. I want to make a quick note about this. So you can set groups for collisions. I'm calling this wall group, and this is actually part of my globals file. I just define the numbers as global variables. This just makes it easier. So you don't have to remember that wall group is 2. You just call it wall group. And so this is how I'm updating. So basically, I'm getting the draw offset here. How I handle the height of the player is I'm actually just using the draw offset. The draw offset is basically there's like a world space, world coordinate system, and you can set the draw offset to basically draw from a different spot in the world space. The coordinate here is 0, 0, and the coordinate here is 400 by 240. And what happens is when you do a draw offset of, let's say, to 0, 10, what happens is it shifts everything down. So instead of 0, 0 becomes 0, 10. And then instead of 400 by 240 becomes 400 by 250. And everything that was, let's say there was an object here at 0, 0, and now appears 10 units down. So you can see that like the player, for example, and there's like a spike here. And what happens is when the player moves up, I'm increasing the draw offset. And what happens is player is staying in the same spot. The amount I'm moving the player up by, I'm moving the draw offset down by the same amount. But the spike is static in the world space. So it appears to move down because we're increasing the draw offset. What I'm doing is by taking the floor of draw offset divided by 120, I'm snapping the value of draw offset to multiples of 120. When the draw offset is like kind of halfway in the image, what happens is it doesn't move at all. But the moment it moves up to here, the height of this block is exactly 120, where it repeats. Once I know it's a multiple of 120, I'll shift it. And basically, that's what's creating like the infinite tiling effect. Okay, so here's how I'm doing the obstacles. I have this parent class. So this obstacle extends sprite. The reason I have a parent obstacle class, I'm checking whether or not something is of type obstacle, then deciding whether or not to end the game. If we look in the player, if collided object is an obstacle, we set hit obstacle true, and then I would display the results. So that's why I felt like it was good to have kind of a parent obstacle class. And the second reason is that I want the obstacle to be deleted whenever the player moves far past it. What's happening is, so the player is here, and there might be a bunch of spikes and stuff off screen. What happens when you go really high, like 300 meters up? Basically, all these obstacles are still loaded in the game, and they're hogging up resources with memory and everything. Let's say the player, it's off screen, but then the player falls back down. You still want the obstacles to be visible, right? So basically, just as long as there's a big enough gap between where the player is and the obstacles where the player won't fall down to that level again, we can just delete that. So I want all the obstacles to by default have that functionality. So what I do is I get the current height, and then I check if the gap between where the obstacle is and the current height is, then I just remove it. I want to mention something really quick about the get current height. So I'm getting the current height, and what is this function actually calling? So this is in my globals file. What it actually is, it's just the draw offset. I'm just using this as a height. However much the screen is being offset by is basically what the height would be. And when I display like, oh, you're 10 meters up in the air, or you're 100 meters up, I'm just dividing the draw offset by 100. And this is just an arbitrary amount. It felt like kind of like a meter. So this is the spike class. So this is just the stationary spike. It's so simple. So I extend the obstacle class instead. Now this is considered an obstacle, and it has the built-in functionality of being deleted automatically if it gets past a certain height. I'm setting the collision box. I'm adding some padding here. So this is just making it so the collision box is just slightly smaller than the size of the image. I'm basically just picking a random X position and then spawning it. As for the Y value, I'll get to that later, but that's being determined by obstacle spawner. Here's how the moving spike works. The obstacle extends a sprite, and then the spike extends the obstacle, and then moving spike extends the spike. So with this dependency chain, what we're having is basically the moving spike inherits all the properties of the spike, which inherits all the properties of an obstacle, which inherits all the properties of a sprite. So you just get all that functionality for free, which is, that's one of the benefits of using object-oriented programming. So this is important. So the moving spike is using the update method because I need to tell it to move left and right every frame. But the thing is, the obstacle class is already implementing an update method. And I want this functionality. So you have to call the super method, or else the moving spike won't disappear once you move past it. And it'll just be stuck in memory. Okay, so this is that kind of platform with a gap inside of it. This is not like, I guess, a great way to do it. Sometimes it's just like, you just need the functionality, and I'm not really gonna touch this code again. As long as it works, it works. There's this YouTuber, his name is The Fluffy Potato, who's a game dev YouTuber. And he had this video that talked about tech debt. So tech debt is when you write code that's not really well organized or architected. Like if you were to go back to that code, it'd be very hard to make changes. But in any situation, even if I add new features, I wouldn't be touching any of this gate code. So what is basically the point of me spending more time trying to optimize this code further or write it in a more clean way? And what happens is it's called debt because you're basically taking a loan in terms of time, how quickly you can implement something. And then in the future, you have to pay back that debt by having to work with that bad code or spend time refactoring it. But if it's like a small project, the thing is you don't actually have to pay back that debt. I give you permission to write bad code if it works, if you feel like you're like, oh, this code is not well organized, how do I write this better? It's like hard to change things. Sometimes it's okay to just kind of rush through it if you feel like, you're not going to go back to it or you're just trying to get it finished, especially if you're a beginner. I would definitely say, because it's hard to tell like when you're writing code that's like quote unquote bad. Code is bad when it's hard to understand and hard to manage and hard to add or take things away from it. You should just write it to make sure it works, and then you can kind of go back and then either fix it or learn in your next project. And which is why like I also recommend beginners to like make really small games, small projects, because you're gonna write bad code and it's gonna be really difficult to add things or change things in it. And then you're just gonna cry because you're like, yeah, like I can't. This code is so unmaintainable. But if you make a small project, you can just finish it and just move on, and you'll learn for your next project, and you write better and better code because you'll understand what it means to write maintainable code. So one last obstacle is this floor spikes thing. So this is separate from the other ones because so those are the spikes that catch you if you're falling, so you don't fall infinitely. But it's kind of different because I don't actually want it to disappear. It should constantly be following you. So what happens is in my update method, I don't call the super method because I don't want it to disappear. So that's kind of something too. You can purposely include or remove it. So like override or extend. Last thing with the obstacles is the obstacle spawner. So this is how I'm managing spawning the obstacles. So basically these obstacles get spawned as you move up. You don't want to like pre-spawn all the obstacles for many reasons. One is the game is infinite, so you technically don't know how far the player will be moving up. So how do you know how far up you're supposed to spawn the obstacles? Two is then you'll have a lot of these objects in memory. What I wanted to point out is that if you remember, I mentioned that each scene, everything is a sprite. So this obstacle spawner is actually, there's no image set on this obstacle spawner. So it doesn't exist as like a visual object. So you might not think it's like, oh, like a sprite, right? Because when you think of a sprite, it's like something that's like you can see in the game. But an obstacle spawner is kind of like a managing system in the background. But because of how I set up my scenes, I'm setting the obstacle spawner as a sprite. And then I'm also adding it to the quote unquote draw list, even though it's not being drawn, because I want this update method to be called every frame. What's happening is this spawn height is, because of the floor function, it's like coercing it into intervals of the spawn gap. Every 150 units or pixels, it's like a multiple of 150. So that's what's creating the gap in between each obstacle. And what's happening is the spawn height is, I'm just checking if it's greater than the last spawn height to make sure that like two obstacles don't get spawned in the same height. So I'm doing some weird math basically. So the current height is I'm getting it from the draw offset, but the draw offset is positive when actually the world space is negative. Let's say the player is at 30 meters up. Draw offset is actually 3,000. But the thing is, the player here is actually at a world space of around negative 3000, right? Because as you're moving up, you're going more and more negative in the y direction. So that's why I'm taking the negative, the current height. I wanted to spawn kind of above the player. So when you move up, it looks like the obstacle's always been there because it's moving into the frame. And then I'm basically picking a random obstacle to spawn. And that's where the Y value comes in from. The player is a long file. So I'm keeping track of the velocity. I'm like simulating physics basically with the player. It's simpler than you think. I'm calling this launch method. Basically, that gets called by the laser gun. It's just setting the velocities to these launch variables, right? If you remember like the unit circle from your math class, I'm basically using like the unit circle. And then let's say you have some angle like this, right? So this is 45 degrees. And if you take the cosine of this angle, what you get is this amount here, this x amount. If you take the sine, you get the y amount. And it's the x and y for like a unit vector, so a length of 1. So that's basically what I'm doing here is I'm getting the x and y values, this angle, and then you can multiply it by the launch strength. And basically you just get an x amount and y amount that you can move the player by. And the reason I'm doing so minus 90 is because the crank, when it's pointing up, we call the SDK function to get the angle of the crank, but like directly up is 0, and then directly down is 180. But directly up is 90 in this case, and directly down is 270. So what you can do is you just subtract 90, and you're basically shifting the unit circle over, and you get 0 to match basically the angle. I guess I can show on the Playdate. Like directly up is this, the SDK gives you an angle of 0, and directly down, the SDK gives you angle of 180, as opposed to like on the unit circle, like this would be 0, right? Or this, I don't know what direction. And so here's how I'm managing the velocity. So what happens is with the y velocity, I'm adding 9.8 divided by 30 because when you're adding and subtracting something from velocity, it's acceleration. Like I'm adding 9.8 meters per second to the y velocity every frame, which is causing it to accelerate by 9.8 every frame. But then I divide by 30 because I want it to be per second, and it's running at around 30 times per second. And the reason I'm adding it is because downwards is positive in the Playdate coordinate system, which is pretty common in game development. And this is, I'm checking against the max velocity. This is basically the terminal velocity. If it's moving downwards faster than a specific amount, then I just cap it out. Okay, so this next thing is the damping. So this is kind of a unique thing that I added. So basically, I found that when you're moving left and right, it felt weird when like it kept going and it wasn't slowing down. Maybe I can show it here. You can see like it moves like the X position is like a constant moving. Like, which is like pretty weird. I don't know. It just didn't feel very natural to me. But when you add damping to it, then you kind of like slow down. See? Which I felt more natural, and it kind of gave you more control, sort of. So that's what the damping is doing, if that makes sense. And it's just kind of something arbitrary I added. You can think of it as maybe like air resistance. So this is how the player position is actually changing. Oh yeah, move with collisions. So that's what's actually moving the player. The laser gun is actually like a child object to the player. So I'm moving it with the player. Yeah, so I'm moving with collisions and I'm checking collisions. So basically I'm just checking if it's an obstacle, if I've collided with any obstacle. And if that's true, then I'm displaying the results. And otherwise, I only have 2 collidable types of objects in the game. One is the obstacles and the other is a wall. So I don't even bother checking if it's a wall or anything. I just know it's a wall. And then I just reverse the x velocity by multiplying by -1. And then I subtract a wall boost amount to move the player up. So this is where I set the draw offset. So how everything is like kind of dependent on the draw offset to get the height. That's how I do it. Let's jump into the laser gun. So the laser gun is kind of interesting because I'm drawing it. I'm drawing a line. So there's kind of some math involved, and I'll show you how I do that. Basically, I'm creating an image like this. So I'm starting from this center position, and then I'm taking the angle of the crank. So let's say the angle is 180 degrees. So the crank is pointing down, and then I use that angle to somehow get this position right here. And I draw a line between those positions. And the way I'm getting this point is by using this get line at angle. It's basically the same math that I was doing. I'm just using the cosine and sine to get some sort of x and y value. And then I'm multiplying this by how long I want the line to be. This point will be 0, 25 if the center is 0, 0. So here's that image. I'm laser gun length times 2. So I'm getting 2 times. So actually this is probably more like this, taking up the whole space. Oh, sorry. So here's how I'm doing it. So basically this is 0, 0. I'm adding the length of the laser. So this would actually be like 25, 25 in the center. I'm getting the angle from the crank, and then I'm getting those two positions, and I'm adding it to x1 and y1. So while this would give me 0, 25, I add this to 25, 25. And what I'm getting is like 25, 50, which is this point right here. What I do is then I just push this laser image to the context, and I draw that line from x1, y1 to x2, y2. So basically, what happens is any angle, I get the x and y coordinates, and then I multiply it, and then I can just draw it into this image. This image will be moved onto the player, like superimposed onto the player. That's what's creating the laser gun, if that makes sense. There's actually still like a visual laser beam that I shoot out, and that's from this laser beam class. What I do basically is I just create a timer. I'm easing between a beam width, which is 10 to 0. Every frame, I'm just redrawing that image. And I'm basically using the same math again, the whole unit circle math I was talking about, to figure out where the line should be drawn. Let's move on to the UI. Okay, so, and then the results display, that's like what comes down, what animates down when, or you hit an obstacle. Yeah, this is a little bit complicated. If you remember, there's kind of this like a fading animation in the background. What I did before is I was calling this draw faded function in my update method. And so every frame, I was calculating this faded image to superimpose onto the background. What was happening was it was kind of lagging. I found a solution to this, which is I just pre-compute everything. I'm creating these images that are fully black, and then I'm fading them with this dithering algorithm. And I'm storing them into this table, like a dictionary. So this is like the fade amount, basically. So it goes from 0 to 55 in increments of 5. And basically, I'm associating these numbers, so 0, 5, up to 55, to an image that's faded. So that makes it so during the game when it's being run, I don't have to draw faded is like a complex like math operation. And instead, I store it as like an image and I'm putting it into this table. During runtime and when it's updating, I don't have to recalculate this. I just access it from this table. And this runs in the very beginning of the game. The thing I'm animating is I'm animating the background, but I'm also animating like the actual dialogue coming down on the screen. Yeah, you see like the background gets faded, and then also like the dialogue comes down. I made animators for both. So the snapshot animator is for the background, and the dialogue animator is for when it's coming down the screen. I'm animating from 0 to 50, which is like the faded value. But what happens is like they're not guaranteed to be multiples of 5 or integers or anything. So I'm doing some math to basically round it to the nearest multiple of 5. And what's happening is I can grab like a faded image based on like how faded I want it to be with this dictionary. And it's pre-computed, so this operation is pretty quick. So I stored a screenshot of the game, the last frame of the game when you hit the obstacle, and I draw that, and then I draw the faded record on top of it. So here it's like this is the screenshot of the game in the background, like right when you hit the spike, and then I draw this like dithered pattern on top of it. That's just creating the fading effect. And then this is moving the dialogue down. So the height dialogue is a separate class. And then when it animates out, I'm just moving everything down like that. So pretty simple. When you hit an obstacle, this function gets called. This is a screenshot that I'm taking. So you can use this handy like graphics.get display image to basically get whatever's on the screen. That's what's happening when like I do this transition. I'm just grabbing the image from the screen and I'm storing it into this snapshot. I'm resetting the height by setting the draw offset back to 0. And then removing all the spikes. So this removes everything with the game. So all the spikes and obstacles and everything. And then I create a results display. Like right as the instant you hit the spike, actually everything about this game state is deleted because you remove all the sprites. The only thing that's saved is the screenshot that gets passed in the results display. And so now the only thing that's actually running in the game is this results display sprite. the dialogue that comes down, it's just a bunch of text basically. I'm like this whole box and this text and everything, press A to restart, all that stuff. I just manually like just wrote some functions to draw it out. So I think this is the title's the last thing that I'm gonna go over. Yeah, so let's look at the title again. So yeah, looks pretty good, huh? So yeah, this idea to basically have everything animating in. Let's watch that one more time. So these are all like just manual, like I just created these animations manually, basically. So they're all like separate images, like this. They're all like I say them as like different. They're like different layers. I'm like loading all these into their own sprites. I'm just setting the start position so they're like off the screen, and I'm moving them off the screen, and I'm just creating animators for all of them. And this is just like kind of I just like fiddle around with the numbers sort of, and then I'm using this last argument is just like how much it gets delayed. So they're all getting called, but like these ones are getting delayed kind of. So then they come in at different times. And then I have all these sound effects, and I'm using this like play at to kind of delay the sound effects of each thing. And while it's animating, I'm just moving it to the animation value, like where the animator is. And that's all there is to it, really. And then it's just like kind of, you're just playing around with the numbers. But it's just kind of a lot of manual work to get those kind of animations, but it's really not that bad. Once the animation is finished, I'm set animating to false. So then it goes into this else block. I start the blinking of the prompt, and then I'm just checking if like the player presses A, and then I switch to the scene with the scene manager. How many hours would I say I put into this game? Okay, so it was like 2 weeks of work. Each week I would work on it for like, I don't know, like 4-ish days out of the week, 4 or 5 days out of the week, because the end of the week I would script and edit the video. Maybe like 20-ish hours, 30-ish hours, 20 to 30 hours, maybe. I don't actually know. That's a great question. Yeah, but I did spend a lot of time on it, and yeah, this stuff takes a long time. Even being like experienced at coding, I'm still learning stuff with the Playdate development. Well, if you made it this far, I think that means you need to subscribe. Check out the Patreon if you want access to the source code files, and see you next time.